In this session, we will learn about what is analysis. So, as we know, if we are having a single problem and we have to define some algorithm to find out the solution of that problem, there are multiple ways. So, there are multiple algorithms available for solving one problem. Let's say we are having a problem for numbers. Let's say we are given 10 numbers and we have to sort those numbers in ascending order, right? So if you know a little bit about the data structure, so there are different sorting algorithms like insertion algorithm, selection algorithm, quick sort, and many more, right? So you can say for solving a single problem means sorting numbers, and there are different algorithms, right? So how you will get to know which is the best sorting algorithm? So here the goal of main goal is to analyze the algorithm, right? And while you are analyzing, you are going to get the best result, or you can say the best algorithm to find out the solution of that particular problem, right? So you can say you compare the algorithms and you find the best solution, right? But you cannot just judge a single program by just comparing the algorithm. There are different other factors which are going to affect the program, right? What are these? First is memory. So you must keep that in mind how much memory a particular program is going to take. And second is developers efforts. Say if a developer is going to take 2 days to complete a task, then that will affect the cost. And if that same developer is going to take 10 days to solve the same problem, then obviously the cost is going to affect, right? So we are not going to talk about the memory and developers efforts here. Let's talk about the algorithm analysis here. So how can you compare the algorithms, right? So first is by the execution time. If you think that the execution time, let's say I'm going to run the program and it takes 4 milliseconds, then I run the program by using different algorithm and it is going to take the 3 milliseconds, and the 3 millisecond is better than the 4 milliseconds. No, execution time is defining your system, because it completely depends what kind of processor you are using or what kind of hardware is there in your system. That's why the execution is affected, not by the algorithm, right? So second thing you will think about is the number of statements. Let's say if that one particular algorithm is written in 10 lines and the another one is written in 100 lines, so 10 lines are better. You would say the number of statements in the program are better. No, it completely depends on the programming languages, right? So if you are going to write in Python, C, C++, Java, and any other language, then it completely depends on that language, right? So number of statements are not defining your algorithm. So what is the way you can analyze algorithm, right? So running time. What is this? Running time of a given algorithm can be expressed as a function of input size and Fn. So actually you can analyze an algorithm by running time. And what is this running time? We are saying it's a function Fn, and this function can be expressed as the input size n. So you say input size means the number of inputs you are going to give, right? For example, if you are having a sorting algorithm, right, and you are given 10 inputs, means there are 10 numbers, right? So if you are going to execute your code according to that algorithm, you wrote the program and simply run that program, and it will take some fn function and there is some value, and then running time is calculated, right? And if I'm going to use the same algorithm for an 100, means the numbers provided to that program is 100, right? So the running time will be different here, right? So the analysis of algorithm can be done by the running time, which is fn. right? So if you want to compare different algorithms, simply take the fn function of that algorithm and you can just calculate that. And this running time is defined in terms of rate of growth. In the next video we will see what is rate of growth. Okay.